Week 5 lecture is regarding the neurological and endocrine or hormonal pathway related to the normal physiology of breastfeeding. In this lecture, we're going to discuss the afferent and efferent nerve pathway that are associated with tactile stimulation and the essential hormones involved and associated in the origins and the feedback. Well, let's start with the neurological pathway that are related to breastfeeding and how do they work in our body. The central nervous system is a system that is characterized and comprise the distribution and regulation of all the other mechanisms of the body. The central nervous system is comprised by the brain, by cerebral hemisphere, we share two of them, and the cerebral cortex. In the cerebral cortex, there are motor areas. The most important part of the cerebral cortex and the motor areas, they are located in the frontal lobes, and they are further defined as the primary motor cortex, the premotor cortex, the Broca area, and the frontal eye field. The impulses for the large pyramidal cell in the motor area travel through the brain stem into the spinal cord via the corticospinal tracts that form the synapses with the lower motor neurons. The axons, which is another part of the neurons, one of the principal parts and the one that really transport the physical stimulation, the motor stimulation, and the reflexes into the rest of the body. The axons, they leave the spinal cord and they will reach all the skeletal muscle fibers with the message. The primary motor cortex is also known as the somatic motor cortex. It is located in the precentral gyrus of the frontal lobe in both hemispheres. The central system, including in all the motor area, is what defines and gives us the sensation of touch, the prior receptors, which are the receptors that let us know where our limbs are, where our toes are, and how we are related to a space. How do we feel our bodies, our ear moving, the breeze of the wind in our skin, and so on. Also, there are sensory areas. The sensory areas of the cerebrum, they interpret the impulses. They are the ones who make us realize what it is. It's a tickle, it's a crawling feeling, it's a touching sensation, it's a warm sensation, and so on. The posterior occipital lobe affects the vision. Also, the temporal lobes, they also affect the hearing. Taste, and smell receptors, they are located deeper within the cerebrum. Sensory fibers also cross similarly to motor fibers, the same way you say. They go from the brain, they go through every single neuron, they pass the axons, and they transmit the message through the spinal cord to every single terminals that is in our body. But it's in this case, compared with the motor sensory, is the sensory areas. This is the one that we're discussing right now. The primary somatosensory cortex lies in the postcentral gyrus of the parietal lobe. It's just posterior to the primary motor cortex, and their neurons receive input from the somatic sensory receptors of the skin. This is important when we relate this to breastfeeding and what the touch does to the newborn as we stimulate the newborn into breastfeeding, into latching, into the forming that bonding sensation that needs to be developed once we do a skin to skin with the baby as we initiate breastfeeding. Moving into that, we're going to go into the deeper part of the brain, which is the brain stem. In this case, we're going to use the brain stem as one of the organs of the brain, the central nervous system. It's called also the older part of the brain, or the primitive brain. The brain stem is comprised by three important parts: the midbrain, the pons, and the medulla oblongata. Going back to breastfeeding and how we can relate this lecture into the breastfeeding pattern, how do we arouse the baby for breastfeeding, what the skin to skin and the touch with the mother and the baby, especially during the first hours of life, we definitely wake up those babies' touch system, sensation system. They will listen to the heartbeat, and all those memories are gonna be motor sensory and a stimuli that is going to help the brain of the newborn into the breast. Also, later on, we're also going to talk about how all the parts of the brain, the motor and the sensory part of the brain, and all the organs that are included into the central nervous system are going to interact in positive feedback, negative feedback, the correlation with the hormonal system, and what are the roles from the motor reflexes and the sensory reflexes regarding the oxytocin, the prolactin, and the milk leg down effects that are also very important and very correlated within the central nervous system. Talking about that and moving forward a little bit, we want to talk a little bit about the positive and the negative feedback. The positive feedback and the negative feedback are regulated by the endocrine system. It helps regulate and maintain various body functions by sensitizing and releasing hormones. The hormone levels in the body are regulated by a highly specialized homeostatic mechanism called feedback. That equilibrium that our body tries to maintain at all time, creating a balance into what we need, what the body we can produce, and how that balance can be always in equilibrium. Due to positive and negative feedback, our body will be always in hemostasis. I'm going to start a little bit with negative feedback. In negative feedback, the responses will reverse or cause the opposite effect of the original stimulus. Positive feedback mechanisms are very rare. Why they are rare? Because they should be initiated, and it's only through that response that we get the positive feedback from our brain and our central nervous system. Positive feedback mechanisms amplify changes rather than reversing them. And this is the key to understand why positive feedback are so rare. For example, the release of oxytocin from the posterior pituitary gland during labor is a good example of it. The release of oxytocin results in a stronger or augmented contractions during labor. These contractions will intensify and increases until the baby is outside the birth canal. When the stimulus to the pressure receptors end, oxytocin production stops and labor contraction ceases. So see, positive feedback.